What if I told you that a computer, smaller than your hand, helped spark a global movement? That it transformed classrooms, empowered hobbyists, and even helped in space exploration? This is the incredible journey of Raspberry Pi. What started as a small educational tool has become one of the most important computing innovations of the 21st century. Grab your soldering irons and microSD cards, because we're diving deep into the evolution of Raspberry Pi. The birth of Raspberry Pi, 2012. Back in the early 2000s, there was a problem. Fewer and fewer students were applying to study computer science. The barrier, cost and access to computers. That's when Eben Upton, along with a team of engineers and educators, founded the Raspberry Pi Foundation. Their mission was simple but bold: create an affordable, accessible computer that anyone could use to learn programming. In 2012, the first Raspberry Pi was born, Model A and Model B. It was tiny, basic, and incredibly underpowered by today's standards. 700 MHz single-core ARM CPU. Just 256 MB of RAM. No built-in storage, just an SD card slot. But at $35, it was revolutionary. Demand exploded. What the team thought would be a few thousand units turned into over 1 million in months. It wasn't just the price, it was the possibility. Suddenly, kids, hobbyists, and developers had a real, programmable computer they could tinker with. Raspberry Pi 2, the first big upgrade, 2015. By 2015, Raspberry Pi had already made a name for itself. But there were still limitations, especially in performance. Enter Raspberry Pi 2 Model B. This was the first major leap forward. 900 MHz quad-core ARM Cortex-A7 CPU. 1 GB RAM. Same $35 price tag. With 4 cores, multitasking became smoother. Users could now build more complex systems, media centers using Kodi, retro gaming consoles with RetroPie, even lightweight desktop environments. And here's where it gets interesting. Microsoft took notice. They released a special version of Windows 10 called Windows 10 IoT Core specifically for Raspberry Pi. This was no longer just a teaching tool. Raspberry Pi 2 proved that a tiny board could punch well above its weight. Raspberry Pi 3, Wireless Freedom, 2016 to 2018. In 2016, the Raspberry Pi Foundation dropped another bombshell: Raspberry Pi 3. What set it apart wasn't just faster performance, it was connectivity. 1.2 GHz quad-core ARM Cortex-A53 CPU. Built-in Wi-Fi and Bluetooth for the first time. No need for USB dongles or Ethernet cables. Suddenly, Raspberry Pi went wireless, and the maker community went wild. With Wi-Fi and Bluetooth out of the box, people began building smart devices in droves. Voice assistants using Mycroft or Google Assistant. Smart mirrors with real-time weather and calendar updates. Home automation hubs with sensors and relays. Raspberry Pi 3 also introduced better power efficiency, making it perfect for portable and battery-powered projects. This was the Raspberry Pi going beyond education and into real-world, functional tech. Raspberry Pi 4, the mini desktop revolution, 2019. Then came the Raspberry Pi 4 in 2019, and it was a game-changer. For the first time, Raspberry Pi wasn't just competing with microcontrollers, it was gunning for actual desktop PCs. Quad-core Cortex-A72 CPU at 1.5 GHz. Up to 8 GB of RAM. USB 3.0, Gigabit Ethernet, and dual 4K HDMI outputs. Yes, dual 4K monitors. From a board that fits in your hand. It became the go-to device for lightweight desktop computing, media servers, personal NAS setups, and even video editing in a pinch. Developers built everything from Kubernetes clusters to 3D printed laptops powered entirely by Pi 4. Pi 4 proved the line between hobby and professional hardware was blurring, and Raspberry Pi was leading the way. Raspberry Pi 5, the AI-ready future, 2023 to 2024. In 2023, Raspberry Pi 5 took another massive leap forward, and this time, it entered the age of AI. 2.4 GHz Cortex-A76 CPU. Dedicated AI processing unit. PCIe support up to 16 GB RAM. Improved cooling and power efficiency. This was more than an upgrade, it was a redesign for the future. Raspberry Pi 5 enabled advanced robotics, real-time object detection, homegrown machine learning models, and serious edge computing. And the price? Still within reach of hobbyists and educators. From automating farms to powering humanoid robots, Pi 5 opened the floodgates for DIY AI. The global impact and future of Raspberry Pi. Over 50 million Raspberry Pi units have been sold. But it's not just about numbers, it's about impact. Raspberry Pi is used in classrooms around the world to teach programming, electronics, and critical thinking. It's embedded in manufacturing lines, smart sensors, and industrial monitoring systems. From drones and ocean buoys to planetary science experiments, Pi is everywhere. And now, as AI, edge computing, and automation continue to grow, Raspberry Pi stands at the center of the next wave of innovation. Whatever the future holds, one thing is clear: Raspberry Pi has transformed how we think about computing. From classrooms to satellites, Raspberry Pi has inspired millions to build, learn, and innovate. So now it's your turn. What would you build? A robot gardener? A home AI? A weather balloon camera? Drop your ideas in the comments. We want to hear them. And don't forget to like, subscribe, and hit that bell for more deep dives into tech revolutions like this one.